Okay. Good morning, everybody. Everybody had good weekends, I trust, full of lots of Python and other fun things. I apologize, starting just a little bit late today. Very thick packet over there, taking the printer quite a while to print. It's this quiz practice.pdf for the electronic version in our topic 7 folder for the class. We're going to today go over, spend our time going over this practice quiz. And the practice quiz, it'll look something like this. The object-oriented programming, or OOP, but not OOP, quiz number 2. And again, this quiz will be not this week, not Wednesday. Your first object-oriented programming quiz will be this Wednesday. But this quiz that we're going over now will be the next Wednesday of class that we have after this week. And again, we don't have class next week because of spring break. So it'll be like, I don't know, 15, 16 days from now that we actually have the quiz related to the material that we're going over today. The quiz itself, the topic information, super important. So it'll be worth 8 points. The quiz this week, the ordinary 4-point quiz, the quiz next class week that we're going over the material for today, worth 8 points. Before we get to the technical stuff about this quiz today, a couple of administrative announcements for us. So first, I guess, big picture idea. What we're going over today will be, or this week, something called binary search trees and recursive data structures. What we're going to see is that this allows us to overcome some limitations of sorting and binary search, sort of getting all the best features of those algorithms without any of the drawbacks, which we haven't talked about too much yet, but we'll talk about this week. So that's what we're building up to. Some announcements. Grades have been fully updated in Sakai, and the grades are overall very good for this class. I'm very pleased so far. The only grade updating that was done was we now have a grader for this course. It's a CGU student, and all they did was just, there's that formula of if you get the green button on GitHub, then they entered full credit minus whatever potential late penalties applied. But so if you think there are any mistakes about things, I tried to go through afterwards, and I know a handful of us have talked about different extenuating circumstances on only doing portions of labs related to collaboration, or maybe adjusted timelines due to other extenuating circumstances. If there are any mistakes related to that, then send me an email and I'll get to those, make sure that those get fixed and your grades are an accurate representation of what they should be. Building off of that, so the first thing I want to say is that I'm extremely proud of you all. You're all doing very well in this class, and this is a very hard class. And over the past couple days, I've been going around to the other professors and bragging about how well you all are doing. And one of the things that other professors tell me often is, or have been telling me the past few days, is that my grades are too high for this class, that I need to make the class harder to bring the grades down. And I 100% disagree with them on that. I think you all are already working extremely hard, and it's already a hard class, and you're rising to the challenge. So I'm very proud of you all for that. The main reason why I think at this point grades are maybe higher in this class compared to other classes are that we have these clear and objective grading criteria that you know exactly what your grade is when you submit your assignments. And so you know if some assignments might be a 5-hour week for you to complete, and some assignments might be a 15-hour week for you to complete. And you know how much effort you need to put in to master the material. And these assignments, again, also interesting things, hopefully interesting, but at least they're preparing you for real-world jobs and technical interviews. Quick aside, over the weekend I pulled a favor, and I want to show you all something a little bit more about how Git works. Right now I'm looking at on our topic 7 folder right here. If we click the actual README file and look at the README file for a second, we still have the same contents right here. But the thing that I want to show you, which is going to tie back into our grade discussion here in a second, is this blame feature. In Git blame, what it does is it tells you who is responsible for making different edits to files. And this is I don't know, something that, I don't know, in normal English, blame has like a negative connotation to it. In Git world and programming world, blame has a neutral connotation. It's just who's responsible for something. And pulled in this favor, and we have a message from Guido von Rossum here. If you click that, you can see it actually is his GitHub profile. Where's that? Actually, there we go. So this is our benevolent dictator for life for Python. And so his message, you guys rock. This is really hard stuff you're learning. Sorry I couldn't make Python any simpler, but at least you can't blame me for your Git problems in this class. Anyways, you'll be using this stuff every day in industry, so keep up the good work. So I want to echo that message that you guys are doing really well in this class, and I'm very pleased about that. Number 3 here, another, I don't know, grade sort of thing. So this is a link to some comments by Google's vice president in charge of hiring people. And one of the things that they constantly say is that GPAs are worthless as a criteria for hiring, and test scores are worthless. So that's a direct quote from the people at Google in charge of hiring, because they don't predict how productive an employee will be. And so that's why they have these technical interview processes at companies like Google or Facebook or startups that you're going to, because the technical interview lets the interviewers really get a good sense of what your skills are and what you're good at and not good at. And the stuff that we've been going over in these assignments, again, very common in these technical interviews. And so one of the goals of this class, besides actually learning the material, is getting you prepared for doing these technical interviews, getting you familiar with the sort of things you're going to have to do. Last grade note here, there's a lot of culture fit things that I bring up in class that are extremely important, but not reflected in your grade in any way. So I just listed a couple of these things here. So things about like how well you use your tools. When you're at one of these interviews at a company, very common for them to have you sit down and just open up your computer and start programming. And one of the things that they want to do is just see like, how do you use your tools? Do you do things like use your screen real estate effectively? Or are you working in just a tiny little window on your screen, ignoring everything else? You don't have to use Vim in those sort of situations, but again, in this class, you do have to use Vim. And so whatever tools you're choosing to use, you should be good at them, mastering them. And so if you were choosing to use Vim in an interview situation, then you would definitely want to have all of the different sort of shortcuts mastered. That there's just a very high correlation between people who know how to use their tools well, who have care about their work enough to put in time to use their tools well, and the quality of code that they're eventually going to be producing for companies. Markdown formatting, again, something that I've been harping on in GitHub issues when it comes up, but especially when you're reporting error messages, getting your code blocks versus your inline code correctly formatted. This is a huge tell about whether somebody is like really thinking like a programmer, thinking like the sort of people who these companies want to hire versus not thinking that way. that you're communicating correctly using standard idioms for communication that's going to make it easier for other people to understand what's going on. Another thing about communication, so pronouncing things correctly, again, this data structure right here is not called a DQ, it's called a DEC. This acronym right here is not pronounced OOP, it's pronounced OOP, or object-oriented programming. And then just addressing people in general correctly. So again, I prefer to go by Mike, not Professor. And when you're working at a company, whatever the company is, if it's a technical company, Facebook, Google, Netflix, startups, everybody will be on a first name basis at those companies. And people will not want to work with you if you're like not using that sort of culture. I know a number of people think that, like, I don't know, using titles is more respectful in the hacker computer science world. Titles are often seen as a sign of disrespect, that if you know that, like if you're working with Guido van Rossum and you call him Mr. Rossum, then you're saying that I don't actually know enough about you to know whether you are like good at what you're doing. And so I have to resort to the titles and whatever credentials you have to talk about you, to work with you, or that's like, I've seen you make a lot of mistakes, and so I don't really have a good opinion of you, but you've earned this title anyway, so I have to have a good opinion of you, so I will address you by that title. So in general, people in the non-tech or in the very technical world prefer to go by either first names or pseudonyms of some kind. Last administrative things, next three homeworks coming up here are all going to be very related to each other, and they're all going to be building off of the homework that is due tomorrow, this week in the containers repository. So they'll all have slightly special instructions. If you scroll down to the bottom of this README file here, then you will find the what those special instructions are for this week, but it involves doing special things with branches. And if you don't do those things correctly, then you will be getting penalized on your assignment. The big picture idea, again, of this sequence of assignments is to simulate the idea of creating a large project that has multiple components going on, and using Git to correctly separate those components from each other so they don't interfere with each other while you're developing. And so if you don't follow those instructions, those special instructions, you won't be able to do the various simulation tasks as they come up. So make sure to pay particular attention to those special instructions. All of these assignments will be more involved than the previous assignments. And again, they all build off of each other. So if you have a problem doing one of the earlier ones, you're still going to have that same problem doing the later ones. So try not to have those problems. I guess easier said than done, but make sure that you get help if you do run into problems. And then because they're more involved, this was a... I guess I forgot to push my last commit here, but there's a typo right here. I'll fix this after class. The first assignment is the one that we'll be going over the material this week for, 32 points. The second assignment is the hardest one, worth 32 points. And the last assignment, the third of these, is in the middle in terms of difficulty. This middle assignment will be worth 64 points instead of 32, and it will not allow collaboration in any way. You'll have to complete it entirely by yourself. So definitely focus on, when you're working on these first two assignments, on making sure that you understand like the big picture debugging techniques of how you try to accomplish the various tasks that you're working on, so that when you get to this third assignment over here, you are able to, you have those tools in your toolkit that you can pull them out when you need to accomplish the task. Yeah, there's no like in-class tests in this class. This project, though, will be sort of kind of like a take-home exam, but it's really just a project. Last announcement for us, modified due dates because of spring break coming up. Everything's just pushed back a week. So we will have a lab this week on Friday. But if you don't finish it in class, then you'll have until the following Sunday to work on it. And similarly with the homework this week, it's not due next Tuesday, but next Tuesday we have classes. Yes, question? Yeah, question is the original containers assignment with the Fibonacci and the range functions and classes, that is due tomorrow. And then the new assignment that this README file here has the instructions for, if you scroll down to the bottom here, these homework instructions, this thing right here is what is due after spring break. Good question. Any other questions about anything administrative in this class at this point? Yes. We will still continue having the weekly quizzes as well, yes. And so next class period, you will have your object-oriented programming 1 quiz, and then the material that will be going out, that will be going over today, will be on the quiz for the week after spring break. And again, all of these, like these quiz topics, are related to what's going on in the homework assignments. So understanding this will definitely help a lot with completing the next 3 homework assignments. Good questions. Any other questions about anything administrative in this class? Okay. Then we're going to start. Yes, question. That's good. Question is that we now have a grader for this class, and if there's some issue about difference of grading in any way, should you email the grader as well as me? And the answer is just email me, and then I'll go through and edit the grades appropriately. Okay, so in order to go over the quiz material, again, oops, where did it go? Here. The shell portion of this quiz is exactly the same as the shell stuff that we've been seeing so far. We will start seeing new things about the shell shortly after spring break, but we're still focusing on Python at this point. And so the Python portion is all going to be new material. And in order to help us visualize exactly what's going on with the Python, we'll be going over to Python Tutor. I've got the first problem from the quiz or the practice problems loaded up right here. And we'll go over exactly what's going on here and how it's different than the OOP1 quiz practice problems. Again, I'm going to be editing this file as we go along, and I'm not going to necessarily, I will follow the order of things in the quiz practice problems, but I'm not going to redo the quiz practice problems exactly here in class. I will do slightly different variations on those in Python Tutor here just to illustrate the main concepts. And the quiz practice problems, you'll have those to actually work through yourself to make sure that you understand what's going on. So let's just go ahead and walk through this code first of all. The thing that's different so far is that we're going to have 2 classes instead of 1 class, and we're going to talk about the different ways that those classes can interact with each other. Press next here, and you can see here that it's created our 2 variables over here, and they're both pointing to 2 different objects. One is the foo class and one is the bar class over here. This is new syntax right here on line 3, where after the name of the class, we have in parentheses the name of another class. We call the bar class here a subclass of the foo class, and we call foo the superclass of the bar class. We also say that bar extends foo and that foo is extended by bar. Again, I'm not going to quiz you on these vocabulary things, but I will be using them. And so it's just important to have an intuitive sense about what I mean by these things. So bar is a subclass of foo. Foo is superclass of bar. And we say that bar extends foo, or foo is extended by bar. The idea of subclassing and superclassing is just a synonym for the verb extending or being extended by. No difference at all, just synonyms of each other. And over here on the right-hand side, you can see that in this square bracket over here, it says extends foo over here, just so to help you visualize what classes are subclasses and superclasses of other classes. Down here, when we do a equals foo, we create the actual foo instance down here. This is an instance of the foo class right here, not the bar class, because we used the foo constructor right here to create it. And then foo.message, put something inside of the foo class. So this is just a review from last time that when you do the class name dot something, this goes into the class object itself and not the instance. And similarly down here, b equals bar, and we do bar.message right here, getting hola mundo. And then we print b.message equals b.message down here. And again, whenever we have an attribute to the right of a dot, the thing to the right of a dot always called an attribute. The thing to the left is always an object. When we have b.message right here, we find the variable up here, the b variable, find what it references. It says the bar instance, and we try to find, is there an attribute of this object over here that has the name of message. In this case, there is not an attribute with the name of message. So because this is a bar instance, we go up here to the bar class and get the message that corresponds to the bar class. And we'll get hola mundo down here as the answer. At this point, everything that we've talked about is just review of the previous week's material. We have not talked about exactly what this is doing right here. That if we were to delete these 5 characters, everything would remain exactly the same. We haven't talked yet about what this is doing. Before we do that, though, any questions about the setup of our problem? Yes. The question is going over the attribute and the instance. An attribute is just the name for anything that appears to the right of a dot. This is an attribute, and an attribute is a special type of variable. Usually we say that variables are these global or local things that are not to the right of a dot, but message over here, this attribute is also a variable. It just happens to be part of the B scope, and so it has this special name of attributes. And because it's to the right, the dot over here is to the right of this B variable, we reference that to get the bar instance down here that was created for B on line 9. And that bar instance is where we're looking for this message. So the object B, the object to the left of the dot, is what we are looking for the attribute to the right of the dot. Or the thing to the left of the dot is the location that we're looking, and the thing to the right of the dot is the thing that we're looking for. The verb instance, or the noun instance, means that because B here, this variable B, is an instance of the bar class, that means that when the message over here, when the attribute does not exist, we will go to the bar class in order to find what the message should be. Okay, I'm going to edit this code now, and we're going to see what happens if I take away line 10 right here. So I'll just comment that out so we can still see what it used to be, but we're going to take that away. And we'll visualize this and come down here to line 11 again. And then you can see that over here in the bar class object over here, there is no message. There is no message over here. And so when I try to do b.message like this, I try to do b.message. Again, we go, here's the b variable, follow the arrow over here to this object. It says bar instance. There is no message attribute under this instance. And before throwing the attribute error though, we have to travel back to the bar class. I know we're going to the bar class because this says bar instance right here. I apologize, the font's a little bit small, but this says bar instance because B was created by the bar class right here. And so we travel back up to this bar instance, the bar class right here, extending foo. There is no message attribute here. So previously we found a message attribute here and we were printing that out. There is no message attribute here. Uh-oh, what did I do? Let's just refresh that. Oh dear. Oh man, what have I done? I will copy and paste that back real quick.
You could take me to play.
In Vim, in order to copy something to the clipboard, so here we go. Here's all the original code I had. I'm going to copy this to the clipboard using the double quotation mark plus yank, like that. There's many different clipboards in Vim. The plus quotation mark is the standard system clipboard. And so this is the code that we had before. I just commented out the bar. There were some comments that I added up here about just definitions. We don't need to care about those. And so this is the situation that we were just at before I did something horrible, which I'm not even sure what it was. And now, again, what we were trying to do, we were trying to see what is this b.message going to give us. The .message attribute, we have b.message coming over here to the bar instance. Then the bar instance, it's not over here in this object. So we come up here to bar and we go over to the bar class right here and we see that there is no message attribute here. But the key thing about extending foo or having this right here means that we don't immediately throw the attribute error when the class doesn't have the attribute. Instead, we'll go up to the foo class because we're extending foo. And here we have this message right here of hello world. And so we will get hello world as our answer right here. The key reason why we get hello world as the answer is because we have this, this extending going on right here. If I edit this code and comment out that part right there, visualize this execution, come down here. Now we go to the trying to access the b.message, and if I press next, we get the attribute error right here because we're trying to go to the bar instance. It does not have a message. We go to the bar class. It does not have a message, and then we stop because this is not a subclass of anything. It does not extend anything, so we're done, and we come down to the attribute error and print attribute error. So the key reason why we were not getting an attribute error before was because we extended the foo class. And so we don't throw the attribute error immediately. We come back up to the foo class and get the message here. Go through a couple more variations on this next, and then I'll pause again for questions in a little bit. I think these variations will help clarify what exactly is going on. So last time, we also talked about constructors for classes, and so I'm going to add some constructors here, def init self, comma, we'll do message equals none like this, and self.message equals message, and def init self message equals none. Both of these will have just the same constructors right now. And down here, the advantage of using these constructors is so that we don't have to manually do something like foo.message, assigning it to something. I can instead just say whatever I want my message to be, passing it inside of these constructor functions directly. Hello world, hola mundo, like this. And if we visualize that execution, close that thing, then this is just exactly what we've seen before, that when you go into one of these constructors, foo here, this hello world is going to be what is going to be the message up here. Again, this self thing, whatever the first parameter is to one of our functions, is always going to refer to whatever the actual object is, and it's not one of the parameters that we count that's being passed in down here. And so if I press next, we can see here's the foo instance that was created, the self variable referring to that foo instance, and then the message hello world being this local variable message corresponding to that down there. And step through this, the self.message sets the actual message in our foo instance, and do that again for bar. And now both of these things do have a message inside of them. And so when I do this b.message right here, we're going to get our hola mundo right here, because that's what b is pointing to. So nothing new. We didn't do anything new in those changes. All I did was add the constructors here to what's going on right here. The first new thing that we'll see here, I'm going to edit this code, and we'll see how these constructors, various ways that these constructors can interact with each other. And so here I'm going to comment this out, and we're going to see a new function right now called the super function. Super like this. When you're inside of a subclass, so bar, we're inside of bar. When you're inside of a subclass, the super function refers to your superclass. So there's our subclass, there's our superclass foo. So this super function refers to this foo class up here. And if I do something like super dot init like so, then I can pass information from my subclass constructor to my superclass constructor. So instead of having to repeat this this line over and over again, I can take advantage of the fact that we already have this line, that we're already doing this thing up here, and just reuse that work. So up here, we'll pass in our message to the init function right here, and we'll walk through that and see what's going to happen. Again, the key thing that's new here is we're using this super function. And so you'll need to make sure that you're focusing on understanding why this is doing what it's doing. So yeah, in order to do that, let's just take advantage of the breakpoints here. I'll put a breakpoint there, I'll press next. Code jumped through 9 different steps just to get to the breakpoint here. In order to get here, we called the bar function down here. Press next again. And that when we call this super function right here, when we call this function super.init, you'll see that the control flow goes from this line right here up to our init function up here. Press next. And now down here, we have two different inits. And so you have to sort of keep track about which one corresponds to which class. You will always have this problem when you're working with subclasses and superclasses in Python, because the constructor always has the same name of init. And we passed this message over here to this function up here, and it's now actually going to run this self.message for us, setting the message of our bar variable right here. Press next, come down here. It's going to now exit out of the constructor for the bar class back to our line down here. And down here, our setup coming into line 11 here is exactly the same as it was before with line 6 versus line 7. These two things do the exact same thing because line 6 calls the constructor for the foo class, which does the exact same thing as the bar class down here. Press next and print out the hola mundo that corresponds to this hola mundo right here. You'll notice that when I'm using this constructor, anytime I'm using a constructor, I'm never passing in this self parameter explicitly. This is something that Python always takes care of for us to pass in. I'm only passing in the variables that are to the right over here. If I didn't have this, let's comment that out. If I didn't have that and just have a pass right here, so again, pass just means do nothing. You can never in Python have a code block that is empty. A code block is something that comes after the colons. You can never have an empty code block in Python. And so if you want to actually do nothing, you just use the pass keyword. Visualize that, and we'll put our breakpoint right here, press next, and all the way through. And now when we run this line 10 right here, we're never going to call the constructors of the, we will call this constructor right here inside the bar function. We call the bar constructor right here, and we are passing in this hola mundo right here, but then we're not doing anything with it because we're just passing right here. So I go next, return value of none, next, we come down here, and if you look at the bar instance down here, you'll see that there is no message created for that bar instance. There is no message down here because we never ran this constructor up here. And so we'll get that attribute error in this case. So you have to be careful when working with these constructors to think about how the superclass constructor is going to get called and used inside of the subclass constructor, and if it's going to get called, and how that's going to affect things. For the quiz problems, these subclass, superclass interactions are going to be relatively simple and again, sort of contrived just to make sure that you are understanding the mechanics of what's going on inside of Python. But for your homework assignment this week, you will have 3 different classes that you're working with. 2 of those classes will have a subclass, superclass relationship, and you'll have to be very careful about how you use these sort of constructor things, and there'll be more complex and interesting constructors going on. Let's do one last example here before I pause for questions. And let's see what happens if I just put a pass right here. So we have no constructor inside of the bar class. Let's visualize this execution, close that, and let's put our breakpoint here. So it'll go up to running the bar constructor, but not actually going into the bar constructor. And here, anytime you're looking for an attribute inside of an object, and here we are in fact looking for an attribute inside of the bar object, the bar object being defined over here as the bar class. Anytime you're looking for one of those attributes, this subclass, superclass relationship applies. And so in this case, the attribute that we're looking for is the init function attribute, or the init method. And so when I press next here, it's going to try to find an init method inside of the bar class. We can see that there is no init method defined inside of the bar class. There is no init method defined down here. And so what Python does is it realize, okay, this is a subclass, so let's go to the superclass up here. Let's go to foo and run the init method for foo up there. So next, and then it does set the message right here and come back down here and prints the message for us getting hola mundo. In practice, in the real world, if you're using constructors inside of subclasses, it will never be something that's just trivial, like manually calling the superclass constructor. It's going to do something additional because if you don't define a constructor at all, it'll just automatically do this for you. That this line right here, pass, is basically equivalent to line 6 and line 8 together, because line 6 and 8 together just makes the constructor for the bar class call the constructor for the superclass foo, and that is the default behavior if you don't actually provide a constructor. Okay, talked about a lot of different variations here between these sub and superclass relationships, and now's a good time to pause for questions. Yes. Question is about this situation here in the subclass. We have defined the constructor for the subclass here, but it is an empty constructor that does nothing. It just has the pass keyword right here. I'll put my breakpoint on line 10. So we go up to not including the constructor for bar. And then at this point, when we press next, we go inside the constructor for bar here, and this constructor will do nothing. So we will never call the you never call the superclass constructor from your subclass constructor automatically. That never happens. The only way, if you've defined this function, the only way this function up here will get called is if you manually call it right here. So here we have the pass, and so we move on. We saw the code flow never went inside this function up here. So we never did the self.message equals, and we get the attribute error because that self.message does not exist. Did that answer your question, Henry? Cool. Do you have a question, Nathan? Cool. Good questions. Any other questions so far? Yes, Miles. So if we have this situation right here, is this what you're thinking? That the contents of the constructors are the same thing?
No, like say online,
like this? So saying afterwards something like C equals foo of hello world. Oh yeah, so the question here is all of these messages that we're referring to are these are attributes of an instance of a class. I know they're attributes of an instance of a class because they have an object that is an instance to the left of them. So these are all self.message. And so when I run all of these things, the final message that we're setting is inside of the instance up here. But the question is, what about if we're setting inside of the classes themselves instead of inside of the foo.message equals salve mundi, something like this. What happens if we have our messages or our attributes that are being applied to the class itself and not an instance of the class? If we visualize this execution here, let's pause right here on line 9, come up to line 9, remove that breakpoint. Here you can see that everything's the same as we've done so far on line 9. When I execute this message right here gets applied to the class up here, this class up here, and then we'll just skip over line 10, run line 10, head to line 11 right here. We have a message inside of the A instance right here. We have this message attribute. And but then on line 11 right here, when I do B equals bar of hola mundo, we'll go inside this constructor and we won't do anything inside this constructor. So the instance B will not have any, the instance B over here will not have any attributes inside of it, and in particular does not have this message attribute inside of it. But whenever we do this looking at an attribute of a object, we always first follow the arrow over here to find the object over here to see what are the attributes that it has available. There is no message attribute of the bar instance right here of this object, but because it's a bar instance, we go up to the bar class and look for the message that corresponds to the bar class. There is no message inside of the bar class, and so the bar class extends foo. So we keep going up to the foo class over here, and we have this message, and it gets us salve mundi. And so b.message like this will in fact be equal to salve mundi, following up that whole big chain of reasoning. There's a lot of variations on this that you'll need to have mastered for your quiz. So what if, for example, I take away this class relationship right here, this subclass relationship, and we come down here again, and now we still have this message up here that's inside the foo class. There is no message in the bar class. There is no message in the bar instance. And so when I do b.message, we'll still come over here, then still come up here, but this is not a subclass of foo, so we won't go from bar up to foo, and we will get the attribute error at this point. So lots of ways that these things can interact with each other. Yes? Question is, here I'm passing in hola mundo. Why am I getting an attribute error? The reason is, so like our ground truth about what's going on is over here on the right-hand side. And here on the right-hand side, we can see B has no message attributes of hola mundo. And the reason for that is because inside of my constructor right now, the things that could actually set that, create that attribute have been commented out. And we just have the pass right here. So we're not actually doing anything. But if I were to change this, take the pass away and say, for example, do this line right here of calling the constructor. And now let's pause ourselves on there we go, pause there and walk through. And we will actually do the subclass constructor call right here. Let's see what is going on. Oh, thank you. I was getting a problem before because I was calling the super class right here, and I had taken away the extension up here, the subclass relationship. So with that foo right there, visualize that and pause that here, go down here, and now go inside of here. When we call the super right here, because I have the subclass right there, it'll go up to the subclass, run that, and then here on line 3, it actually sets the message attribute right here. And then down here, line 13, it has this message attribute right here. And so it will not get the attribute error. So these problems, like, they get very, very tricky because there are many, many things interacting here, and a subtle change to one part of the code will have profound implications on how other parts of the code end up working. Good question. Question? Mm-hmm. So I believe this is the, I believe this is reproducing your question down here, that here we have under our B bar instance, there is no message. Under the bar class, there is no message. Under the foo class, there is no message. But under the A variable over here, the A instance, there is a message. And the key thing about instances is that they are always totally separate from classes. A class can never know about its instances. An instance can only know about its classes. So when you're looking things up for an instance, you might have to go to a class, but if you're looking things up for a class, you will never go to an instance to look for things. And so at this point, we will try to do this b.message, and we'll check this instance, we'll check this, but we will not check this other instance down here. And so we do get the attribute error. Did that answer your question? Okay, all great questions. I want us to move on, though, to the next section of the notes, and I have this opened up down here. The first problem, this is of section 2. What did we call that? The static methods. And then this 2.1 without inheritance, problem 17 right here is what I have opened up in Python Tutor and what we're looking at this point. So here, all of the functions that we've explicitly talked about for our quizzes, there's only been one function that we've been talking about, this init function right here. But you can have an arbitrary large amount of functions in your classes, and most interesting classes will have many functions that work together. One of the things that makes the next couple programming assignments harder is that there are going to be about a dozen or so different functions inside of different classes that you'll have to be implementing, and they will all work together in various ways. Each individual function by itself is not too hard by itself, but the fact that they're all having to work together in weird ways is what makes it hard. So here, our first new thing here is this other non-constructor function that we have right here. So we'll walk through this and then talk about what's going on. So everything at this point is the same as we've seen before. On line 6 right here, we called the constructor with hello world and set the message for that instance. And then down on line 8, this is where our new thing is happening, that we have this a.foo right here. A.foo. Again, anytime you have something to the right of a period, we call that an attribute. This is a special type of attribute, which is has a value of a function. And these special types of attributes are called methods. If you have a function to the right of the dot, it's customary to call that a method. But if you have a function that is not to the right of the dot, it's just customary to call that a plain old function, just a function. Every method is a function, but not every function is a method. Here, when we run line 8, we will first have to find what is the foo function. What is the foo function for my particular A instance right here? The A has no foo function inside of it down here. So we go up to the foo class to try to find the foo function. It is extremely common, 99.99% of the time, your instances will not have functions inside of them, and the functions will be defined inside of the class that the object is an instance of, and you will get the function from the class instead of the instance object. Line 8 right here, when we run it, we're going to go into the foo function inside of the foo class right here. Press next. We go up here inside of this foo function. Again, we have this self parameter up here that we don't actually apply down here. So this, we say this method requires 0 parameters. This method requires 0 parameters, even though we are passing in this self parameter when we're actually defining the method right here. And then all this method is doing is very simple. It's just returning whatever the self.message value happens to be equal to. So we have our self right here. We reference it over here to this message and get hello world as our result. And that's what we will print out, hello world up here. This type of method right here, it has no special name. It's just a method, ordinary method. Sometimes if we need to be specific, we'll call it a non-static method. But even though this is in the section on static methods, at this point, this problem has not introduced the idea of a static method. It is just an ordinary method or a non-static method. Any method that takes self as its first argument will be a non-static or ordinary method. This is not a hard and fast rule in Python. Python never looks at the names of your variables to determine what it's doing, but this is a convention that is so strong that if you were to break it, then Guido will personally come and yell at you. If your first parameter here is self, then you are always an ordinary non-static method. So what exactly is a static method? I'm going to delete this self right here, and I will add a @static method like this. Again, anytime you see this syntax in Python, this is modifying the function that it follows. This function, again, is a method. So that's why we have static method up here. So we're modifying this function or modifying this method right here. And anytime you see this @static method, you will never have the self as the first parameter. So this is now a static function or static method. now a static method. Hopefully reasonably obvious why it's called that based on this function or this decorator right here. The at syntax again is in Python is referred to as a decorator because we are decorating this function with special attributes. The special attribute we're decorating it with is staticness. So this foo right here is a static method. And because there is no self parameter being passed in here, we cannot refer to self right here inside of the function. If we do that, we'll get a name error because this variable right here does not exist. And so in order to do this, every static method, if it is accessing something about the class, which it probably should, it will be using the class name. Static methods access class attributes instead of instance attributes. So here we need our message to be a class attribute in order to access it from the static method like this. Let's visualize this execution and we'll see what is going to happen here. Press next. Here, we run our constructor just like normal. At this point, nothing is different because we haven't called this foo function at all. Again, you can see up here inside of our class that we have this foo method that's been defined. It tells us over here that it's a static method instance. So if you forget or can't decipher it from the left-hand side for whatever reason, it tells you that it's static and not an ordinary method over here. And now when we come, the thing that'll be different is that on when we get inside that function, what's going to happen? Here, press next, and we're going inside the static method. Again, there is no on line 16 right here inside this a variable. There is no foo attribute. There is no foo attribute of the a object. And so we look at the foo attribute of the foo class up here to figure out what to do. And we'll press next. Going inside of our foo function right here. And then at this point, we do return foo.message. And when we do that, even though we called this from an instance, here A, we called it from an instance A, which has a message available to it. Because we're doing up here foo.message and not self.message, we are not going to be able to find the message up here in the foo class. Remove these breakpoints here. And let's go ahead and press next here. We'll see that we get this attribute error down here because the foo class does not have the message attribute. The A instance does have the message attribute, but again, when you're inside of a class looking at things for classes, you never go back to instances to find the attributes. You only go from instances to classes. And so I press next and we'll come down here and get the attribute error as our actual result down here. This is not using anything at this point, not using anything fancy or particular about static methods, because we could have changed our ordinary method to return foo.message. That would be an acceptable thing to do. If I were to, I'll comment out both of these lines. Actually, I'll comment out all three. And up here in the non-static method section with a self like this, it would be perfectly acceptable for us to do foo.message like this. That when you're inside an ordinary method, a non-static method, if you're inside this method, you can still access the class. If you're inside an instance, you can still access the class. But this version down here is inside the class. Static methods are inside the class and not inside the instance because there is no self variable here to reference. And so you can't access self from a static method. Just visualize this real quick and jump all the way to the end. And you'll see that we're still getting the attribute error right here because we're doing foo.message instead of self.message. If this was self.message, no attribute error. Because it's foo.message, you do get an attribute error. I'll pause here in a second for questions. So this begs the question of what would we have to do in order to fix this problem, in order to make this not be a attribute error. There are many ways that we could fix that. One is that we could add an attribute up here. Again, when you put an attribute inside the class itself, this attribute right here can have no idea of what instance it belongs to because there is no self involved right here. And so this has to be a class attribute. It has to be foo.message. And if I visualize this, let's put my breakpoint right here, line 17. So we won't actually run that yet, but press next and just look at the contents of my foo class object over here. So all I've done is run this first line, and we've created a foo static method, and we've created this sometimes called a static attribute message, salve mundo, but it's just a class attribute, this thing that only applies to the class and not to the instance. And now when I come down here on line 19 right here and run this a.foo, well, I guess it's creating the instance first. There we go. So it just created the instance right over here with my foo instance with message inside of it, and there's the A. If I go inside of a.foo now and come over here, and now when I do line 16 right here with this foo.message, because the foo class does have a message inside of it, I will get this salve mundi right here and not the hello world down here as what gets printed out. Let's verify that up here. It is in fact salve mundi. So this begs the question of, again, why would we want these static methods if they are somehow strictly inferior to the ordinary non-static methods? They can do less things. A static method can do less things than an ordinary method, and an ordinary method can do everything that a static method can do. Why would we ever want a static method? And the answer is that sometimes we don't actually have a class instance to work with, but we still need to do something related to that class. If we come down here, I press edit. And now down here, instead of a.foo, I do capital foo.foo. We won't even create an instance anywhere. We have no instances of this. We have no instances of this foo class because on line 17, I commented that out. So we're just going to go straight down to line 19 here as soon as I press next. And we will never call the constructor up here. We will never create an instance. We will never run this self.message line. But we can still access this foo static method right here, just off of the foo class like that. If I press next and we go inside this class, and everything will work without an error, printing out salve mundi. So the advantage of a static method is that you can use it without having an instance of your class. That might not seem like a big deal for the purposes of the quiz, but again, the quiz is not focusing on the why, it's focusing on the how and the what. And your assignment this week, when we talk about it on Wednesday, we'll talk about the actual application of why this is good programming practice to do sometimes, having static methods versus non-static methods. Said a lot of stuff right there really quickly, so I'll come up for questions. Yes. Question is, does having instances around affect how the static methods work when you are calling them from the class object instead of an instance object? And the answer is no. That I'll put a breakpoint here. So we'll come up to line 19, not execute line 19 yet. But you can see now there is an A variable created over here. It does point to this instance over here. This instance does have a message that says hello world right here. And now when I do this foo.foo like this, it's not going to affect anything at all. It will never access any of these attributes or information about this foo instance. And so we're just printing the salve mundi that comes from right here, totally ignoring that there's this hello world attribute at some point. This is also true, and this is getting extra confusing now, that if I change this capital foo, this class object, to the instance object like this, and I use the static method from an instance instead of from a class, I'll use the static method from an instance instead of from a class, it's not going to have any effects at all. Just jump all the way to the end, and we still get salve mundi down here. even though on line 19 right here, I have a.foo, and the message for a is hello world. But because I'm using a static method and the static method does not have a self, the static method has no idea that there's instances anywhere in the world. It only knows about class objects and not instance objects. It only knows about foo.message and not self.message. Where the static method will do the salve mundi even when I call it from the a variable from this instance down here. Very easy to get confused because of just so many references going on. Question? Question is, what if we had over here self.message? And let's just see what's gonna happen real quick. I'm gonna press last to take us to the last line of code. Okay, I'll step through it one at a time. Let's put a breakpoint right here on line 19. So we'll create the instance, create everything exactly the same. The only thing that's going to be different is going into this static method and seeing what's going to happen here. So I'll press next to go into this a.foo. And it's totally okay to go into a static method again from your instance. Press next. And now here, when I have this return self.message right here, return self.message, what's going to happen? Well, we have no self variable that we can access right here. There is no self inside of this function right here. And so Python is going to throw an error for us. We get the name error thrown right here, name error thrown right here because self doesn't exist. Turns out that in Python, every error message, every exception is a class, and there's a subclass hierarchy of exceptions. And when we do accept attribute error down here, yeah, never mind what I was saying. That was too much of a tangent. But did that answer your original question? Here it doesn't know there's a message. That's why it threw an error. If it's capital foo.message like this, it does know there is a message because I'm going to put a breakpoint right here. We'll execute just up until this line of code right here. And you'll see that it knows there is a foo.message because over here in this foo class right here, there's a message attribute salve mundi, which is created on line 2 right here. So that's why this is an acceptable thing to do, whereas self.message was not acceptable. Does that answer your question? Cool. Okay, all great questions. I want us to press on, though, to the very last section of the notes. Scroll down a little bit more to, so there's things that we didn't talk about how the static methods interact with inheritance. I expect you all to look at the examples to figure out how that works. We've talked about everything. It's just there's more big combinations of lots of stuff going on here. So making sure that you can work through those sorts of problems. And we're coming down this last section on recursive classes. So I know everybody enjoyed recursive functions and everybody's enjoying classes right now. So we will combine all of the joys from both worlds into this one section right here. And what's going to happen? So we have a much simpler class now. It only has a constructor inside of it. And we've seen this exact class before. All it's going to do is, so I'm going to execute line 4 right here to go into the constructor and do our self.message. So now we have our foo instance right here, and it has this message attribute of hello world. Everything up to line 4, 100% the same as things that we've seen before. Line 5 is where things start getting a little bit new. And actually, it's still stuff that we've seen before. It's just done in a different context. Here, if we do, say, foo.child like this will create a new attribute. This will be a new attribute of the foo object, new attribute down here, which will be named child. And its value will be another foo object over here. Press next. we're going inside the constructor over here. So we're creating the instance right here, a new instance right here. And our self is just a reference to this instance. Our message here is Hola Mundo, because this here, the value being passed to this constructor is Hola Mundo. Press next, and we'll set the message for this second instance over here, like that. And come down here, go back. So just to make it clear what's going on, we've executed this constructor completely. We have not done the entirety of line 5 yet, though. So we execute this whole constructor, and the constructor is going to be a reference to this instance over here. And now when I finish executing line 5, the child attribute of this foo instance right here, so foo.child, foo refers to this variable right here. So this instance right here will have a new attribute .child, and that attribute will reference this instance over here. I'll press next. And you can see a new attribute child was just created. It has a reference pointing to this foo instance down here of Hola Mundo. And I press this same exact thing is going to happen down here on line 6, only now the child is not going to be of this original foo instance. It'll be of this foo instance down here. Also notice that this foo instance down here has no direct variable name up here inside the global frames. The only way that we can access this foo instance is by accessing it through its parent foo instance up here. I will put a breakpoint right here. So we'll just execute line 6, construct it, create the child attribute right here. So we constructed this Salve Mundi right here, Salve Mundi from here. And it is a child of this foo instance. It is a child of the child of foo right here. Now, when I come out down here to print this value, foo.child.message, how do I know which one of these messages are going to get printed? Well, I just go left to right with my objects. I go foo, so here's foo, and then there's a dot, so it means I'll be following a reference, so .child. So follow this reference, here's the child. That foo.child right here is equal to this child right here. And so this instance right here is what foo.child itself is referencing. Then I do the dot message. So get the attribute of this particular, so foo.child.message. Foo.child was this instance over here. Then the message right here, Hola Mundo. Press next, and we get that Hola Mundo is being printed. If I were to change this, edit this code to delete these .childs like this, then this would be exactly the same stuff that we've seen before. These two lines here would be having no effect on anything. And so if I press last, jumping to the end, we get the hello world out here because foo.message is hello world. More complicated, if I do foo.child.child, foo.child.child, like this, visualize that execution, and we'll just jump to the end. Last, we get Salve Mundi because there's two child references here. I follow both of these two child attributes to get this instance down here. One last complication is, what if I try to go too far, add too many children, .child like that, and jump to the end? We'll get this attribute error because this last child over here, referring to this instance over here, does not have a child attribute. And so this is good, this is good, this is good. This right here is not good. That part throws us the attribute instance. One last weird thing for us to see is that what if instead of foo.child equals foo like this, what if I make that actually equal to foo? So now we're going to have circular references. I'm going to put a pause right here, jump to the end. And so this instance right here, this child refers down to this instance right here. This child right here refers back up to this original child right here, and it keeps going in a loop forever. So now, no matter how many childs I put right here, no matter how many times I write .child, we're never going to get an attribute error, and we're just going to actually print something out. That's very fast through that last little bit here. If anybody has questions, happy to take them after class, but we're out of time. So Again, none of this material on the quiz on Wednesday, but you do have a quiz on Wednesday, so good luck with your preparations for that. And happy to stick around and answer any questions that people have.